Hi everyone, welcome to today's tutorial on solving the happy number problem on LeetCode. In this tutorial, we will explore a fascinating problem that involves the concept of happy numbers and how to determine if a given number is happy or not. Throughout this tutorial, we will focus on the most important concepts that will help you grasp the core principles of this problem. By understanding the key insights and techniques, you will be equipped with the knowledge to tackle similar algorithmic challenges. So without further ado, let's get started. First, let's discuss the intuition behind the solution. Understanding the intuition will help us grasp the underlying concept and reasoning behind the code. A happy number is a positive integer that, when repeatedly replaced by the sum of the squares of its digits, eventually reaches the number 1. On the other hand, if this process enters a cycle that doesn't include 1, the number is not happy. It's not a happy number. So to determine if a given number is happy, we need to identify if it falls into a cycle or eventually reaches 1. And that's where our solution comes into play. The approach involves the use of two key techniques, cycle detection and storing previously seen numbers. By detecting cycles, we can determine if a number is not a happy number. Here is how it works step by step. First, we define a helper function called a get next number that calculates the sum of squares of the digits of a given number. This function will be used to calculate the next number in the sequence. Within the main function, we initialize an empty set called sim. This set will help us keep track of previously seen numbers. And then we enter a while loop that continues until the current number n becomes 1. This loop will iterate as long as we haven't reached a cycle or the happy number 1. Inside the loop, we check if the current number n is already present in the scene set. If it is, it means we have encountered a cycle and the number is not a happy number. We immediately return false from the function. If n is not in the scene set, we add it to the set. This allows us to remember the numbers we have seen so far. Then we update the value of n by calling the getNextNumber function. This calculates the next number in the sequence by summing the squares of its digits. The loop continues until we either find a cycle or n becomes 1. If we reach 1, we exit the loop, and we know that the number is a happy number. In this case, we return true from the function. And by efficiently keeping track of previously seen numbers and continuously calculating the next number in the sequence, our solution detects cycles and determines if a number is a happy number. Understanding this intuition will help us better comprehend the code and its purpose. Now that we have explored the intuition, we can dive into the time and space complexities of the solution. Understanding the complexities will give us insights into the efficiency and the scalability of our solution. The time complexity of an algorithm measures how the execution time increases with the input size. In our case, the input size is represented by the given number, denoted as n. When we analyze the code, we can observe that the while loop is the primary driver of the time complexity. The loop iterates until the current number n becomes 1 or until a cycle is detected. The number of iterations depends on the properties of the input number and its transformation sequence. In the worst case scenario, if n is not a happy number and the transformation sequence enters an endless cycle, the number of iterations will be limited by the length of this cycle. As we discussed earlier, the length of a cycle is typically much smaller than n itself. Therefore, the number of iterations is proportional to the size of the cycle rather than the magnitude of n. In terms of time complexity, this translates to an approximate time complexity of big O of log n, where n represents the given number. And moving on to the space complexity, we need to consider the additional memory required by our solution. In our code, we use a set named sim to keep track of the previously seen numbers. The space used by the set grows as we encounter new numbers in the transformation sequence. In the worst case scenario, if n is not a happy number and the transformation sequence does not reach 1, we might end up storing all n distinct numbers in the set. The number of distinct numbers stored is limited by the length of the cycle. Therefore, the space complexity is also proportional to the size of the cycle, leading to an approximate space complexity of big O of log n, where n represents the given number. These complexities demonstrate that our solution is efficient and can handle large inputs effectively. It scales logarithmically with the size of the input, making it an optimal solution for the problem. And that wraps up our tutorial. I hope you found this tutorial helpful in enhancing your problem-solving skills and understanding algorithms. Remember, the key to solving algorithmic problems lies in breaking down the problem, identifying patterns, and designing efficient algorithms. I encourage you to continue practicing and exploring more LeetCode problems and other coding challenges. The more you practice, the more proficient you will become in solving these types of problems. Thank you for joining me today. If you have any questions, please leave a comment, and also please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Happy coding, and thanks for watching. Goodbye.